गुड इवनिंग बच्चा लोग. I hope we are live. Please confirm in the chat box my voice is audible. Am I clearly audible and visible to everyone? Yes, we are live. Shall we begin? What discussion we were having? I think we talked about gear part is complete. Gear train is also complete. And today we have to talk about analysis of single slider crank mechanism. Velocity analysis, acceleration analysis, how these things are going to be done. What is going to be our approach? Let's discuss that. So, sir, velocity and acceleration already haven't we done? Yes, we have already done it. We have some methods, we have developed some methods where either by using eye-center method or by using relative velocity method, you can analyze. You have already done the analysis of velocities. You have a single slider crank mechanism, crank का velocity if you are given. So what will be slider का velocity, slider का acceleration, connecting rod का angular velocity, connecting rod का angular acceleration, what will be these things? Already we have find out. But what is the need of this chapter then? Why we are again performing kinematic analysis? Beta, whatever we have studied till now, those all the methods were a little time taking, है ना? And if you are expert in those methods, you can analyze, you can do analysis of any mechanism. But this mechanism this single slider crank mechanism is something unique. It is most commonly used mechanism. If I talk in terms of whatever mechanisms we are surrounded by, so in terms of volume, in terms of numbers of mechanisms around us, so you will find that this single slider crank mechanism is very widely used. So that's why, because this mechanism is very widely used, so instead of again and again repeatedly, instead of drawing the mechanism, finding out the eye centers or drawing the velocity diagram, it is time taking. So I want some formulas. Just give me one formula. In that formula I will put some values of theta, angular velocity, dimensions, and I want exact velocities quickly without wasting my time. So what is my intention? I hope you have got it. First, let's talk about kinematic analysis. Kinematic analysis. And when I say kinematic analysis of single slider crank mechanism, what is the meaning of this? Sir, kinematic analysis का simple सा फंडा है that if we are talking about something which is having translation, so your aim is to find x as a function of t, and once you have x as a function of time t, so velocity dx by dt, you will get the velocity. If velocity is also a function of time, so for acceleration dv by dt, rate of change of velocity is nothing but acceleration. So by this method we can find out, velocities, accelerations, everything. Kinematic analysis means this. If something is having rotational motion, so parameters will be that let's find out theta as a function of time t, and once you have theta as a function of time t, then what will be omega? D theta by dt. And what will be angular acceleration? D omega by dt. Simple si baat. What is this? I'm just telling you that if you are having something which is having translation, so this is going to be our approach. And if something is having rotation, our approach will be something like this. Find out theta as a function of time t. Your main aim is to develop this theta as function of time t, or x as a function of time t. Rest is just mathematics differentiation. So I'm not going to give you formulas here. I'm just giving you the how diagram looks and what is the process. After that, we just have to perform differentiation. Now, careful. Kinematic analysis of single slider crank mechanism. So the single slider crank mechanism can be anything. This can be your IC engine. This can be part of your compressor or any other mechanism. This is the line of stroke of the slider, and I have my crank. Crank is rotating like this about some fixed axis. It is rotating like this. So at any instant, when my crank from its initial position, theta is equal to 0 is this, it is rotating clockwise direction mein, and when I'm seeing it has traveled some theta angle, it is moving with some omega angular velocity, constant omega angular velocity se rotate kar raha hai, and it has traveled some theta angle. Connecting rod is here, and I'm having, this is my slider. Pin joint, pin joint, pin joint. Clear hai baat? This is your fixed link. Situation is this. What I want, that sir, initially this crank was at this position, so connecting rod was also horizontal and piston was here. And from this position, this position I'm taking as my reference position. From this position, how much we have traveled this angle theta. From this position of the piston, how much distance this piston has traveled. And from this configuration, initially my crank was here, connecting rod was here. It was also horizontal. So my connecting rod is a link which is doing translation plus rotation. So what kind of translation? Arey sir, translation it is doing with this piston only. So whatever is the translation properties of this piston, same translational motion this connecting rod is going to have. Arey bhai, piston ke saath mein, with the piston I have just pinned this connecting rod ka one end. So whatever is the velocity of the piston, translational velocity of the connecting rod will be same. So now I want to know this connecting rod which is actually doing general motion, which is a combination of translation plus rotation. Sir, translation ka idea I have already got, same as piston. Rotation, I want to understand this. What is the meaning of rotation? Sir, initially your crank was here, connecting rod was here, and piston was here. So connecting rod was initially horizontal. And once your piston has traveled this distance, connecting rod also has traveled this distance, translation same. But at the same time, it has also rotated by some angle. So I want to explore this rotation also. What is this angle? Getting my point? So what we are going to do here in this, what we are going to do here in this entire process, I hope everybody has got it. So from this, starting from my reference position at any general time t, when I saw crank has traveled some theta angle, in that time my piston, this is my piston, from its extreme end it has traveled some x distance. And if I'm talking about my connecting rod, it has connecting rod ka rotation I'm talking about, so it has traveled some angle beta. About this crank, let's have one assumption that I'm assuming that this crank is rotating with constant omega, although this crank can have some angular acceleration also, but I'm not analyzing, I'm not developing formulas for that situation. That is a different situation, keep that in mind. If my crank is rotating with constant omega, this is my assumption, let me write. Most of the time what happens, people just remember What are the formulas? They forget on the basis of what assumptions we have derived these formulas. So if these assumptions are violated, these formulas cannot be used. Assumption kya hai? That crank is rotating with constant omega. Constant omega means it is connected with some motor kind of thing. And if it is connected with motor, so rate of change of theta is nothing but omega. I can write d theta by dt is nothing but omega. Sir, about this crank, I have all the idea. How? About this crank, I have all the idea. How can I say this? Array, this is rotating with constant omega. Velocity I have given, motor I have attached. So I know what is this omega, and with this omega at different point of time, what will be my theta? I know this. This motion I know. Because of this motion, what will be motion of this connecting rod and what will be motion of this piston? I want to explore this. So let's talk about piston first. Sabse pehle let's talk about piston. How we are discussing this? Sir, let us suppose this radius of the crank is given as r, connecting rod length is given as L, and for this single sided crank mechanism, there is a term which is defined as obliquity ratio. Obliquity ratio, let me call it obliquity ratio. It is defined as N, ratio of L is to R. Generally, this value of L by R is more than 1. Obviously, we have already studied this, that if in this single sided crank mechanism, if this crank has to do rotation, complete rotation, so R must be smaller than L. So obviously, L will be larger, R will be smaller. So L by R ka value is more than 1. And most of the time, generally this value is of the order of 4, 5. This value is of the order of 4, 5. Sometimes in examination, they say that this is very, very large. Especially when you're talking about steam engines. Steam engines may, this value L by R looks of the order of 10, 15, 20. Hai? So that I will say that it is very, very large. 4, 5, large value. 10, 15, 20, very large value. So generally it is large. Of the order of 4, 5. It is of the order of 4, 5 at least. It can be more. Examination, they will clearly mention that it is very, very large. Then only you have to consider it very large. Otherwise, generally it is large. By default, it is large. Okay, how we are analyzing this? My aim is for the sake of doing the motion analysis of this piston, I am assuming I am trying to find out what is the x as a function of time t. But sir, finding out x as a function of time t is not that easy. Finding out x as a function of theta is easy. At this particular theta, what is my x? When crank has traveled by theta amount, what is my beta? So I will find out x beta as a function of theta. Theta is a function of time. That means your x is a indirect function of time t. Can I say this very easily? Bataiye. How can I find out this? Sir, starting में this value was R, this value was L, so this total value was L plus R, and from this L plus R, if I subtract this value, I will get the x. And what about this value? This value ko I can write something. What? I can write this as, drop a perpendicular here, drop a perpendicular here. Can you write this? From here till this point, can you write this value as this plus this value? And what is this value? This value is nothing but, sir, it is R cos theta, this much. And what is this? Sir, this value is L cos beta. So ultimately what you have got? X I have got as entire from here till this point. This was L plus R. So L plus R minus this plus this, minus R cos theta minus L cos beta. I have got this Beautiful value. What is the approach? My work is done. As a theory of machine faculty, my work is done. My work was just to tell you that how this mechanism look, what is the assumption here, what is the obligatory ratio, that's it. Now, how I have find out this x? X we have. X is a function of theta and beta. I can say, sir, beta is not an independent parameter. Beta also depends on theta. I can write beta in terms of theta also. कैसे लिखेंगे? How I can write this? You can write from this triangle. Look at this triangle and look at this triangle. Both these triangles have this perpendicular as common side. So can I write L sine beta, this one, and R sine theta, this one? Both are same. Can I write, sir, L sine beta is same as R sine theta? So can I write sine beta is sine theta divided by L, and R is above, so I can take this R this side, L by R. And what is this value of L by R? Sir, L by R ko we can also write as N. So can I write sine beta as sine theta divided by N? Can I write it like this? Acha, I want to find out cos beta ka value. Sine beta is in terms of theta, you know. Cos beta we can write. What is the value of cos beta? Cos beta can be written as, sir, let me come to the next page. Cos beta I can write cos square beta plus sin square beta is equal to 1. You know this. Sin square beta, you can write something in terms of theta. Sin square theta by n square. So this goes this side, becomes negative. So we will be having 1 minus sin square beta is sin square theta by n square. This is the value of cos square beta. So cos beta will be under root of this entire thing. And under root of this entire thing can be written as n square goes this side. N square minus sin square theta inside the root. And under root n square, it can be taken out as n. So we have got this cos beta as under root something divided by n. What value you want to find out? Cos beta ka value I have got. Careful. What I am doing? I am just doing mathematics. I am doing nothing. Simple mathematics. Let's simplify this. Can I take common R? So what I'll be having? I'll be having this side L by R, which is n, plus R becomes 1 minus R has been taken common. So inside we are having cos theta minus L by R is again n cos beta. And sir, n cos beta is under root something. Can I write this? So my this expression, which was x is equal to something, it can be written as, क्या लिख सकते हैं? This expression can be written as this expression I have got. I can write this expression as x is equal to r n plus 1 minus cos theta minus n cos beta can be written as under root n square minus sin square theta. Under root n square minus sin square theta. That's it. So this was your aim. I wanted to find out x as a function of time t. I wanted to find out like this. But sir, instead of writing in terms of time t, I have easily written x as a function of theta. Theta is a function of time t. Can I say x is a indirect function of time t? So in this situation, velocity is actually dx by dt. But sir, this is not direct function of time t. So you can also write it like this. Dx, whatever function you have in terms of theta, you can differentiate x with respect to theta and d theta by dt. Now you have got some velocity. Velocity is a function of theta. Differentiate it again. So what you will be writing? Sir, वैसे तो I write acceleration dv by dt, but velocity is not a function of time directly. It is a function of theta, so I can write this as dv by d theta by dt. Getting my point? And what is this d theta by dt? Sir, d theta by dt is nothing but omega, angular velocity of the crank. I have already written this. D theta by dt is already I have written omega. So wherever you get d theta by dt, put omega here. Here also one omega will come into picture. So that's how we are going to find out x. We have velocity, acceleration I can write. What will be velocity? Velocity कितना हो जाएगा sir? Velocity will be dx by d theta. So differentiate this entire term with respect to theta and d theta by dt. D theta by dt is omega. So one omega is coming into picture. We are having r omega d theta by dt omega. Inside the bracket, whatever we have, differentiate with respect to theta. So with respect to theta, n is constant 0, 1 is constant 0, minus cos theta becomes cos theta is minus sin theta. So minus minus plus sin theta minus inside the under root we have some theta wale terms. How do we differentiate this? It will be theta raised to the power half. So it becomes half whatever term we have under root, whatever term we have, n square minus sine square theta, its power n minus 1, half minus 1, minus half. What is the meaning of minus half? Under root 1 upon under root. So can I write it? This term, can I write it like this? This is under root 1 upon. And now this term is not exactly theta, it is something something theta. So differentiate this also. It becomes n square, differentiation 0, minus sine square theta, differentiation becomes 2 sine theta. Now sine theta ka differentiation cos theta. So this is the simple sa differentiation which I have done. Simplify this. Sir, can I write velocity is equal to r omega? Inside the bracket we are having sine theta. This minus multiply, it becomes positive. So plus 2 sine theta cos theta is sine 2 theta. We are having sine 2 theta divided by 2. Inside the root we are having some big term under root n square minus sine square theta. This is the answer. Well, if you are asking me what is the velocity of the piston, when crank has traveled theta angle, so this is the exact velocity. This is the exact velocity, but I don't need to remember this big formula. Why I am saying this? Because this n ka value is generally of the order of 4, 5. N square, 4 square, 16. And what is this sine value? Sir, sine ka value is something between 0 and 1. And this term becomes 16. And sine square theta, sir, sine square theta is between 0 and 1. It may be sometimes half, 0.4, 0.5, 0.6. So something which is less than 1, if you are doing its square, it becomes even lesser value. So this value is quite big. This is very small. So can I write for large values of n, for large n, this n square minus sine square theta, approximately, I can ignore this sine square theta, it will be approximately equal to n square. Can I write this? And if you will do this, so sine square theta, n square minus sine square theta can be written as n square. Under root n square is n. My expression is coming out to be velocity is equal to r omega sine theta plus sine 2 theta divided by 2n. This is the formula which you can very well use in every place. Why? Because n is large. By default, it is large. Okay? But this is not the exact value. This is approximate value. GATE examination mein, we have to remember this. Don't wait for the examiner to say n ka value is large. No. I know that n is large. I'm not waiting for your confirmation. I know n is large. If examiner has said that n is very, very large, if n is very large, and bete, examiner clearly mentions that n is very large. Steam engines wala case. If n is very large, like in case of steam engines, so for the very large value, very large ka matlab n ka value is 20, 15. So if this n is 15, sin theta is already less than 1. So something which is less than 1 divided by 20. So this term becomes very, very less as compared to this thing. So I will ignore this entire term and I will be left with only sin theta. So velocity is equal to r omega sin theta. This expression I can write only when we are talking about very large value. Otherwise, gate examination we have to use this formula. Let me know in the chats if everybody is comfortable till this point or not. Subhash Jain, sir, if I am watching a lecture of 3-4 hours, it is taking me 11 to 12 hours to complete. Why? 3 hours lecture, even if you are watching it at 1x speed, it must take only 3 hours. After watching the lectures, you have the PDF. By seeing the PDF, you have to make the notes. So for the 3 hours lectures, you are making notes for 8 hours. That makes it 12 hours. I don't know what you are doing. Are you doing the group studies? Group studies with this kind of situation may arise. इधर ग्रुप स्टडी करने बैठे थे. I was doing group study and suddenly someone said, "Oh, let's go for a tea." And we started the bike. We went for the tea. But the tea outside my house is not good. So we went a little ahead. And I saw the board, Manali, just 250 kilometer. So we thought, let's have some fuel and go to Manali. We will have some Maggie with chai. Group study is very dangerous. No, 11-12 hours is too big. Hardly 3-4 hours lectures. 3-4 hours lectures may I am believing if you are watching it at 1x speed, and just like a live session, so you have understood it clearly. There is nothing left for your analysis. Sir, I have seen your lecture. Now I am trying to absorb this. There is nothing like this. So 3 hours lectures, you have spent 3 hours. You have completely understood this. And now you just have to make the notes. It shouldn't take more than 1 or 2 hours. Even like in theory of machine, we have some diagrams. So if you are making diagrams very clear, neat and clean diagrams, even then also it shouldn't take this long. You are doing some mistake. Acha, but once we have this velocity for the piston, we can talk about acceleration all apart. Acceleration kya hoga? I will start from this. I'm not taking the exact value. This value I can, approximately this value is not having much error. Why? And value is large, so I haven't done much mistake here. I have simply written this. So what will be acceleration? Kya hoga? Sir, velocity ka formula we have. V is equal to r omega sin theta plus sin 2 theta by 2n. This is the velocity ka formula. Acceleration kya ho jayega? Sir, acceleration is dv by dt, but velocity is not a function of time. It is function of theta. Theta is function of time. So what I'll do, dv by d theta by dt. D theta by dt omega. Another omega comes into picture. So already we have omega. Another omega comes. So it becomes r omega square. Differentiate this with respect to theta. So this becomes cos theta plus sin 2 theta becomes cos 2 theta into 2 and divided by 2, and we have, so this 2 gets cancelled and I'm left with n only. So this is your acceleration formula. When this formula is valid? For n large values it is valid, and this n ka value is generally large, so gate mein I can very well use this formula. If n is very large given, so this n ka value is very large, cos 2 theta is already less than 1, so something less than 1 divided by very big value, you will ignore this entire term. What we are left with, acceleration is r omega square cos theta. That's it. Gate mein we are going to use this formula. So I'm not saying that you have to memorize this formula. I'm not giving any formula to memorize. I am just giving you the process, how we have started the things. Just find out x, and then we have to do some basic differentiation, some basic maths. Even if you want to memorize something, you can remember only one formula. Just remember this velocity wala formula. Acceleration, examination hall mein I will just differentiate. If you will remember two formulas, you will jumble these formulas. Sir, acceleration ke formula mein cos theta tha or it was sin theta, I'm not sure. Velocity ke formula mein it was 2n or acceleration ke formula mein it was 2n, I'm not sure. So if you have so many things in your head, there are huge chances of confusion. Less things in your head, less chances of confusion. Okay? So this velocity and acceleration of the piston we have find out. How questions are asked? Simple formula based questions. Exam they will ask, they will give ki radius is how much, length is how much, so n ka value they have given, and when my crank has traveled 30 degree, theta ka value they have given. Crank is rotating with some speed 400 500 rpm, r ka value they have given. Tell me what is the acceleration of the piston, what is the velocity of the piston. So they have given the all values, theta they have given, and they are asking velocity and acceleration how much it is. Simple. Second thing, sir, piston ka velocity acceleration I have developed the formulas. Now we can talk about connecting rod. Connecting rod ke bare mein karna kya hai, what we have to do? Sir, my intention is, again, connecting rod is doing general motion. Everybody must understand this. Connecting rod is doing general motion. Road translation, I am saying same as piston. I am focusing on this. I am trying to find out the rotational part. How this rotational part I am going to handle? Sir, acha, from where this rotation I am seeing? First of all, I am seeing this rotation when I am ignoring the translation. I am sitting at this point. Beta, how many of you can imagine this? If you are sitting at this end, this pin end, so obviously baat hai, you are moving, translation you are doing along with the piston. Connecting rod is doing translation along with the piston. And now at this pin joint, you can see that initially it was horizontal. How much angle it has traveled, how much beta it has traveled. So this guy is doing the analysis. This one. Who is doing this one? Try to find out what is the value of beta in terms of time. Sir, beta is a function of time I wanted, but beta writing in terms of time is not that easy. Beta in terms of theta I can write. Already I have with me. Sin beta is equal to sin theta by n. Already I have this function. From where I have got, just we have derived this. Differentiate both sides with respect to time. Beta is a function of time, theta is also a function of time. Differentiate both sides. This side also and this side also. d by dt of sin beta, it becomes cos beta d beta by dt equal to sin theta becomes cos theta d theta by dt. What is this d theta by dt, sir? D theta by dt is nothing but angular velocity of the crank. What is this d beta by dt? Rate of change of angular velocity. यही तो है एंगुलर स्पीड ऑफ द कनेक्टिंग रॉड. दिस इज एंगुलर स्पीड ऑफ द कनेक्टिंग रॉड विच यू आर ट्राइंग टू फाइंड आउट. है ना. तो क्या हो जाएगा, व्हाट इज द एंगुलर स्पीड of the connecting rod? Omega of the connecting rod is equal to omega cos theta divided by n, and this cos beta goes this side. Sir, n cos beta, already I have written something. Come here, come here, come here. N cos beta under root something I can already write, under root n square minus sin square theta. Can I put this value? This entire thing under root n square minus sin square theta. Can you write this value? So what is your omega of the connecting rod? Omega of the connecting rod, you have got omega cos theta divided by under root n square minus sin square theta. This is the exact value, but I don't need this exact value. I don't need this exact value because I know that n ka value generally it is large. N is large generally. So can I, n square will be very, very large as compared to this. So I am just ignoring this sin square theta wala term, and under root n square minus sin square theta approximately I can write as n square. So I am left with angular speed of the connecting rod is equal to omega cos theta divided by n only. This value in examination, gate examination, you have to remember this, but this is not exact, this is approximately, but I can, without much error I can use this value. Angular speed of the connecting rod, differentiate again, है ना. Angular acceleration of the connecting rod, it is differentiation of d omega of the connecting rod d by dt, but it is not a function of time, it is function of theta. So you can differentiate it with theta and multiplied by d theta by dt. D theta by dt is nothing but another omega. Another omega will come into picture. So what is the formula I have got? Angular acceleration of the connecting rod, I have got connecting rod differentiate with respect to theta, omega n remains same, cos theta becomes minus sin theta, so this minus sin theta, and d theta by dt is omega, so omega becomes square. We have got this formula. Simple si baat. So I have written 4 formulas in front of you. You have to decide, do you want to remember this, do you want to memorize this, or do you want to understand this? Okay, examination mein direct formula based questions they are going to ask, direct formula based questions. After completing one lecture, you should immediately solve whatever DPPs have been given. First thing, solve the DPP. This immediate second thing is solve the PYQs, topic wise PYQs. Gate wala ka book if you have. So we have chapter wise segregation we have done. Inside the chapter we have given topic wise questions. So if you have today, you have, suppose you have just completed velocity analysis, velocity mein eye center wala question. So if you have today studied the eye center wala concept, you can now solve the eye center wale all the PYQs, है ना. Or after completing each topic, just don't fall for the topic wise PYQs, because there are some PYQs which require knowledge of more than one topic, है ना. So I would recommend complete one chapter and then start solving questions topic wise. You have to do this. ठीक है. So this was kinematic analysis. what we are doing in the kinematic analysis part. I hope everyone is clear. Let's talk about the dynamic analysis. What is the meaning of dynamic analysis? For the very first time, we are going to talk about dynamic analysis of single slider crank mechanism. Careful, careful, careful. For the very first time, we are trying to find out what are the forces acting on different components. We are trying to analyze that. How things are going to look. Sir, we are having a crank. Again, single sided crank mechanism. We are having a crank. It is rotating, and from its 0 degree wala position, inner dead center say it has traveled some theta angle. It is here. Connecting rod is this side. This is the line of stroke. This is the line of stroke. And we are having piston like this. Okay? Careful, careful, careful. We are having pin joint here, we are having pin joint here, we are having pin joint this side. And we are also having cylinder. Where is the cylinder? Sir, cylinder is this side. This is how your cylinder is going to look. Careful. ऐसा कुछ we are having situation. While solving this dynamic analysis question, I am having one assumption that this is not a compressor now. Earlier situation what we have seen, it was single sided crank mechanism, but I was talking about compressor. Means my crank was having some input, and because of this, what is the velocity here, what is the velocity here, I was finding out this. Now here when I'm talking about dynamic analysis, I am seeing single sided crank mechanism, but input is given at piston. What is the meaning of this? I'm talking about engine. I am talking about engine. So this single sided crank mechanism is my engine now. Engine है, so obviously बात है, there will be some forces acting on it. Piston पे there will be some force acting, and net force acting on the piston if it is given to you. Gate examination में it is given कि भैया on this piston net force acting is something. We call it as piston effort. And because of this force acting on the piston, there will be some force developed on the connecting rod, and that force will be transferred to the crank. It will rotate the crank, and crankshaft rotates. That we use in our wheels, that will be transferred to the wheels. That's how IC engine is, any engine is going to work. So objective question में this piston effort का value they have already given. They subjective question में they will make you calculate this piston effort. कि cross section area will be given, what pressure of the gas is there, it will be given, friction is acting, friction will be given. So you have to find out what is the net force acting on the piston. But objective question के point of view से they will never in the history of the gate they have never asked such question where they have made you calculate the piston effort. They have given the piston effort. ठीक है? Now because of the piston only, because of this piston effort only, all other forces will be developed in all the components. What are the components? ध्यान से समझना. Let me I will not solve any question here, but let me just give you a brief idea. If they ask you to calculate the piston effort, what does it mean? Piston effort, net force acting on the piston. First of all, it is piston effort FP say I'm denoting this. It is called as net force acting on the piston. Net force acting on piston. What are the forces acting on the piston, sir? Piston में one force is acting which is gaseous force, है ना? I must take care this gaseous force. Gaseous forces कैसे निकालेंगे? अरे they will be giving you कि cross section area of the piston is given. This side से combustion is happening, so whatever pressure is built up, so that pressure multiplied by area, you will get how much is the gaseous force. Okay, gaseous force plus we have to add all other forces which are acting in the direction of motion. Piston is moving in line of stroke direction, horizontal. Sometimes engine is vertical also, so piston will be moving in vertical direction. I have to consider all the forces which are in the direction of motion. So friction is there, sir. Friction is always opposite. If my piston is moving this side, so friction is opposite direction में. If my piston from here it is coming this side, so piston relative motion को it will always oppose. So gaseous forces minus friction force. Any other force, sir? I can't find any other force. You have written all forces, all the forces you have written. Now I will add inertia force here. And what is this inertia force? Opposite to acceleration. Inertia force is written as minus ma. Minus is indicating that it is always opposite to the acceleration. What is the acceleration of the piston? Sir, acceleration we just have studied that a acceleration r omega square cos theta plus cos 2 theta by n. We have this formula of the acceleration. Put the acceleration into mass negative sign के साथ में. So you have got this inertia force. Add the inertia forces also. Its sign may be negative or positive depending upon which theta you are talking about. So whatever you have got, put this value. I'm not saying subtract the inertia force. I'm saying add the inertia force opposite to the direction of acceleration. So minus ma already I have written. Minus ma. Now you will solve this. If this term, cos theta wala term, if this term is becoming negative, so this negative will become positive. If this term is positive, so positive and this negative becomes negative. So sometimes it will be minus of something or sometimes it will be plus of something. Depends on which theta we are talking about. So we have put the inertia force. And if sometimes we are talking about vertical engine, if my piston is moving upward, up down situation mein, so I have to consider weight also. And weight, if your piston is coming down, so bhaiya weight is supporting this motion. But your piston, if it is moving up, so weight is in opposite direction. So I don't know. Sometimes we will use plus or sometimes minus mg, but this mg only for vertical engine, vertical mounted engines के case में I will talk about this. So if subjective question you are solving, so this is how we have to consider the total piston effort on the piston. This is net force which is acting here. Clear है बात? अच्छा sir, I can understand everything, sir. Gaseous forces I can understand, friction force I can understand. If it is not a vertical engine wala case, so this mg will not be in the picture. What is this inertia force? Why you are adding this? Please give me the feel of this. Inertia force क्या होता है? Try imagining this. Suppose if I am having a cart means, है ना sir, ये this is a cart like this, है ना? You have seen these kind of carts on which I have some vegetables. I'm just selling the vegetables, and you are this seller. You are just pushing it. Now imagine that this cart is moving and you have maintained a constant velocity and a frictionless surface hai, and you are you have just pushed it a little and it is moving with some constant velocity, and that constant velocity, say you are just traveling. So how much force you are applying on it? Sir, no force, because friction is not there. So once it has some velocity, I'm just maintaining that velocity. I'm moving along with it. If you want to accelerate this, if you want to speed up, hai na? What is the meaning of speeding up? Sir, you are speeding up. Acceleration is in this direction. This cart is moving here with v velocity, and acceleration if you want to produce, so you have to apply some force. And imagine I have some huge quantity, hundreds of kg vegetable is there. So if you are trying to accelerate this more, this cart is heavy, you will feel you have to apply more forces. You are, pushing it, you will feel the inertia force, that it seems that inertia force is opposing the motion. On the other hand, if it is, if its velocity has increased too much, now if you want to reduce the velocity, you suddenly jumped this side and you are trying to hold it, ki bhaiya just stop. You are trying to stop this. Now this very heavy, hundreds of kg vegetables cart, it is moving with some high velocity, 50 km per hour constant velocities it is moving, and once you try to stop this, you will feel that acceleration is where? Sir, velocity is in this direction, you are trying to reduce the velocity, that means acceleration is now in the opposite direction. Let me make the two different diagrams. First case mein I have shown this guy was pushing it, acceleration is in this direction, so inertia force, this guy will feel that inertia force is acting in this direction. You can feel the inertia forces opposite to acceleration. And on the second situation, if the same cart is moving in this direction, but this guy is ahead of it, and this guy is trying to stop it. Now acceleration is where? Sir, body is moving in forward direction, acceleration in reverse direction. Sir, acceleration is in the reverse direction, and you will feel that this very heavy cart is pushing you around. You will feel that force. What is that? Inertia force. You will feel that this body, because of its mass, because of this its heavy nature, it is pushing you around. You are opposing this, ki bhaiya just stop, your velocity is too high, but this heavy thing is pushing you. Inertia force. Because of the inertia property, this force comes into picture. So this force, when you are accelerating this body in this direction, force will be acting here. Getting my point? So inertia force may be in this direction, or maybe velocity in the direction of the velocity, or in the direction of opposite to the velocity. There is no relation with the velocity. Inertia force is always opposite to acceleration. Getting a point? And once all the forces you have added, and you have also added the inertia force opposite to the acceleration direction, all forces acting on the body, that summation becomes 0. This is your D'Alembert principle. D'Alembert principle. What this principle says, that whatever net forces are acting on the body, if you just add inertia force vector, vector means, sir, it may be in this direction or maybe in this direction, plus or minus, I don't know. All the forces plus inertia force, that summation becomes 0. This is something which is called as D'Alembert principle. So based on this, I am further solving my question. So you have, while calculating the piston effort, sir, piston is having some mass m, it is, because of the gaseous force, it is moving ahead. If it is having acceleration ahead, so inertia force will be opposite direction mein. And piston ka motion, how it is, sir? Piston ka motion, we just have seen piston ka motion is simple harmonic motion. At least when we are talking about n is very large, it is actually simple harmonic. SHM motion, we have seen, sir, what is the velocity of the piston? Sir, piston का velocity होता है v is equal to r omega sin theta. SHM motion. This is simple harmonic motion. What about this, sir? This is also sin theta के terms में. It is harmonic motion, but it is not that simple. It is sin theta, sin 2 theta divided by something. So it is complex harmonic motion. This is simplest harmonic motion. And simple harmonic motion का मतलब क्या होता है? Sir, velocity from 0 it increases to maximum till the midpoint, and after that it starts decreasing. So first half of the stroke में acceleration is there, second half of the stroke में de-acceleration is there. So acceleration is sometime this side, after half of the stroke acceleration is opposite direction में. So acceleration के opposite direction में we are going to have inertia forces. So inertia force sometimes piston की motion को it will support, sometimes it will oppose. First half में when piston is moving this side, acceleration के साथ, so inertia force is opposing it. And rest half of the stroke में when piston is moving ahead but its velocity is decreasing. Velocity is decreasing means acceleration is opposite in this direction. So inertia force will be in this direction. Inertia force will be pushing the piston ahead. Getting my point? So once you have all these forces, you have calculated gaseous force, friction force, inertia force. In case of vertical engine, mg plus or minus, we have to check. Once we have calculated piston effort, now we can start our analysis. Acha, keep that in mind. Why I have gone this into this much detail? Because if I make free body diagram of my piston, careful. If I make free body diagram of my piston, how does it look? Sir, you are having connecting rod in this direction. How much angle it is making? Sir, it is making some beta angle. This is beta angle. So what is the meaning of free body diagram? First of all, sir, piston ko detach from every connection. It is connected to connecting rod. So connecting rod will apply some force on it. It is also in connection with the cylinder. So cylinder will also apply some contact force, normal direction mein. So on this piston, how many forces are acting? Sir, on this piston effort is acting. We just have calculated. Gate examination, but this will be directly given. Piston is applying some force on the connecting rod. Piston is applying some force on the connecting rod, which is I'm saying as FC, which directly gets transferred through the spin joint onto the crank, and we can take some components of this force perpendicular to the crank and along the crank. So we can take its one component here in this direction and one component here in this direction. We call this component as this component multiplied by radius r. It will be providing you some torque. So I call this component as torque providing component, FT. This is called as crank effort. And what about this component, sir? This component is of no use to us. It is just radial direction mein it is thrust on the crank bearing. Radial thrust FR. है ना? So somehow if you can find out because of this FP, how much force is there, so you can take components, you can find everything. Sir, this is the FP acting on the piston. Piston has applied some force FC. So how much connecting rod has applied on this action? Every action has equal and opposite reaction. So opposite direction where we are going to have force like this. This is your FC. Sir, we have this cylinder wall के perpendicular direction where we are going to have some normal reaction. Contact force is always perpendicular to the surface. This is called as Fn. And keep that in mind. On this piston, all the forces which are acting here, and inertia force I have already included here. So all external forces including inertia force makes summation 0, D'Alembert principle. That means all these vectors, their summation is going to be 0. What is the meaning of this? Sir, if I add these vectors, so this is Fp, this is Fc, and this is your Fn. I think all these forces, they must form a closed polygon. This is the meaning when I am adding 3 vectors and resultant is 0. That simply means that we are going to get a closed polygon. Everybody, is this clear or not? I have got this situation something like this. What are these forces? Sir, this is your Fn, this is your Fc, and this is your Fp. Fp I know, this is angle beta, this is 90 degree. All other forces, can you calculate in terms of Fp? Fp I know. Can I write simple? Can I write? Somebody is asking, tell me what is the force along the connecting rod. I can write Fc. Sir, Fc cos beta is same as Fp. Can I write? Fc cos beta is Fp. You know what is the value of Fc? Fp upon cos beta. Once you know Fc force along the connecting rod, once you know, we can also talk about Fn, normal thrust. कैसे निकालेंगे भाई? Can I write tan beta is Fn upon Fp? Sir, tan beta is Fn upon Fp. Configuration is given, beta ka value they have given, Fp you have calculated. What is the force normal to the cylinder wall? Fn ka value is Fp times tan beta. That means, what is my intention? What we are doing here? I am just trying to find out all the forces. Why all these forces are developing? Because of the piston effort only. Piston pe some force is acting, and because of this some forces are being developed. All other forces in terms of Fp we are trying to find out. And once you have Fc ka value with you, so Fc ke some components we are going to have. Can I write? If this is angle theta, this is angle beta, so outer angle will be theta plus beta, property of the triangle. So Fc ka cos component is Fr, radial thrust. Sir, Fr is how much? Fc ka cos theta plus beta component. Fc ki value is how much? Already we have calculated. And we can also calculate what is the value of Ft, crank effort. Sir, Fc ka sine value, sine theta plus beta. It is that easy. Sir, are you giving me formulas? No. I am not giving you formulas. I am not giving you formulas. Theory of motion and vibration mein Vishvajeet Verma has never given formulas to any student. What I am telling you, I'm just showing you how diagram is made. We are talking about engine. Piston pe there are some forces acting. What forces we have considered, and then we have taken components, geometries, blah 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 blah. That's it. That's it. And once you have Ft, so because of this Ft, I'll be getting some torque also. Bhai, this is the force multiplied by radius r. You will be getting some torque. If you are asking, if exam mein they are asking, tell me what is the value of torque. So that torque or turning moment, Ft into radius r. That's it. That's it. Tell me in the chats, are you comfortable or not? Sir, how is this inertia force opposite to acceleration? I have given you a clear idea. With the help of that example, cart wala example. Imagine karo, one body is coming towards me. That cart is coming towards me. I am standing here. One cart, it is empty cart. It is coming here, and I have to apply some force to stop it. This is empty cart, and another cart is having 100 kg of vegetable. It is also coming towards me. Both are having the same velocities. They are coming towards me. Sir, something which is having 100 kg mass on it, its mass inertia is quite high. So its inertia forces will be quite high. This is empty cart. Its mass is very, very less. So for me to stop this is very easy. This card is coming towards me. I have applied some force. I am applying force on it. That card is applying force on me. Getting a point? On the other hand, if I have to stop that heavy 100 kg vegetable wala cart, if I have to stop that, I will feel ki, oh ho, that cart moving with the same velocity, but that cart is applying force on me. Why? Because I am trying to push it. I am trying to apply brake on it. It is having velocity in this direction. So I am providing retardation, deceleration. Its velocity I am making it to reduce. So its retardation is in this direction. So how much inertia force I am feeling? Acceleration ke opposite direction mein. Now I hope you have got it. Try to feel things. है ना? There are two ways to understand concepts. Either you can understand it mathematically. Sir, show me the derivation mathematics, or you can close your eyes and you can feel the concept. Physically you can feel it. So I think that this feeling wala part is very easy and important also. है ना? Mathematics mein you can make some mistakes, but if you have developed the feeling for the concept, you will never fall for the trap. Examination mein, gate mein, they will make a trap for you. ठीक है? चलिए, so kinematic analysis, dynamic analysis, what we are doing. I hope this is clear to everyone. ठीक है? I haven't given you formulas. I have just given you some concept, some beautiful concept, and based on this concept, you can solve questions very easily. This is my Telegram group for everyone. You can join this group and you can be in touch with me always, and you can direct connect with me. You can direct talk with me if you have any problem related to theory of machines, subject say related any problem. You can have conversation with me. In that group we have 4,000 5,000 people, like-minded people who are preparing for the gate, so you can have healthy discussion with them also. Let's stop. Tomorrow we will meet and we will be discussing chapter flywheel. What is flywheel? Where it is used? How does it work? What benefit this flywheel is going to have? What is the mass of the flywheel required? Everything we will discuss. Tomorrow, sharp 8, we are going to start. Till that time, thank you, bacho. Goodbye. Love you all.